You requested me to solve for you question number 5, tutorial 2. So on this tutorial, it tells us that a car travels due north for 1/4 of the time. And we were told that the car also then traveled due south for 3/4 of the time. So mathematically 1/4 of the time is equal to 1/4 times t, which is t/4 seconds. So that was the time which was taken as the car moved along due north. Same applies to due south. 3/4 of t is equal to 3/4 multiplied by t, which is equal to 3/4 t, which is 3t/4 seconds. So this is the time which was taken to move along due south. The velocity, the average velocity as the car moved due north was 72 meters per second, and the average velocity as the car moved due south was 71 meters per second. So from these two columns, this information, two rows, we can calculate the displacement as the car moved due north, and we can also calculate the displacement of the car as it moved due south. How do we find the displacement? Its change in x is equal to the velocity multiplied by the time as the car moved due north. Also, the change in x is equal to the velocity multiplied by the time as the car moved due south. So 72 meters per second multiplied by t/4 meters per second. The second and the second, it cancels. The other one's a numerator, this one's a denominator. Then the units, they cancel, seconds and seconds. Then we are left with only 72 meters over 4. Okay? Then we are going to multiply also this. It will be 71 meters per second multiplied by 3t/4 seconds. Seconds and seconds, they cancel. Then we'll be left with 71/4 meters multiplied by 3t. So don't forget the t. The t is also multiplying the 72. Okay. So the only units which are cancelling here is the s and the s. So our change in x is going to be 71 meters times 3t. Then here the change in x will be 72 meters times t. Okay. So taking north as positive, the car is starting from here, it moves due north. Then from due north, it moves due south. So it's just a sketch of roughly to indicate what is it that is happening. So from initial due north, then it moves due south. So at the end of the day, we want to calculate the average velocity for the entire trip. So we know as it moved due north, it was 72 meters per second. As it moved due south, it was 71 meters per second. So we want to find the average velocity of the entire trip. That is our question. Like I've explained before, displacement due north, that is the change in x equals to v times t, which is 72 meters per second multiplied by t/4 seconds. So the second and the second, they cancel. What are we left with? 72/4 t meters. Okay, don't forget the t. So if you simplify this, it's going to give you the change in x of 18 t meters due north, because this is what we are calculating for the meantime, the displacement due north. Then we calculate the displacement due south. Then we add the total displacement to find the total displacement. Okay? So the total displacement due south is equal to the velocity, to the change in x. That is our displacement, which is the change in x, which is equals to v times t. So due south is 71 multiplied by meters per second multiplied by 3/4 of the time, 3/4 of the time, 3/4 of the time it was moving due south. So it's 3/4 of t seconds. Then the seconds, they cancel each other. We are left with meters multiplied by t. So 71 times 3 is 213 t meters divided by 4. So we get our answer is 53.25 t meters due south. Okay, so this is our displacement due south. And we know the total time is for the entire trip is t, since we were referring to as 1/4 of t moving to the north and 1/4 of t, 3/4 of t moving to the south. So if you add 1/4 and 3/4, you are going to get 4/4, which is just t. 4/4 of t, which is just t. 1 times t is t. 4/4 of t is still t seconds. So this is t, the total time, which is a number, and this is a unit second. Okay. So taking north as positive upwards, the average velocity for the entire trip is equals to the total displacement over total time. So which means you are going to add the displacement due north plus the displacement due south. Then we divide it by the total time for the entire trip, which is t seconds. Okay. So we know that this car moved 18 t meters due north plus another 53.25 t meters due south. The total time taken for the entire trip is t seconds. So the average velocity, taking upwards as positive, north as positive, so it's going to be 18 t meters plus, that is the plus, okay, plus 53.25 t meters due south. Okay, it will give us a negative here because we are moving in the negative north direction. But if it was south, if it was north, it was going to be positive. But since we are going the negative of the north, it's the south. Okay, so that's why we had put here a negative, because we are going to the south. If the final answer is negative, which means the average velocity's direction will be southwards. But if the final answer is positive, which means it's northwards. Okay, so adding the two is going to give us, and then dividing at the same time by t. So it's going to be 18 t meters plus negative 25 t meters over t seconds. So it's going to give us this, when you add them, it's going to give you negative 35.25 t meters. That is our total displacement. Okay, it is negative 35.25 t meters. All right, our total time, remember, it's t seconds. Then if you divide, obviously these units are going to cancel, T and T cancel, and you'll be left with meters per second, which are the units of average velocity. Velocity's units are meters per second. Okay, the T and the T, they cancel. The negative, it implies we are going in the southerly direction. Okay. All right, so just to interpret our answer, so this is the average velocity for the entire trip, which is negative 35.25 meters per second. Taking into account that upwards or north as positive, so which means this we are going in the negative direction, which is the southwards. So if you are asked what is the magnitude of the average velocity, the magnitude, it's only the size. You don't include the negative sign. The negative is not included, which means this is not part of the magnitude. It's just showing you the direction. Okay, so the magnitude will be 35.25 meters per second. Magnitude is always positive, is the absolute. The absolute of any number is always positive. So magnitude is always positive, but the direction, that is what is indicated. If it's positive, then you know it's going upwards. If it's negative, then it's going southwards. So the direction in our case is going southwards. So the answer was supposed to be magnitude and direction. So you are going to give your answer as a magnitude and direction. So the average velocity is equals to 35.25 meters per second southwards. That is your magnitude and the direction. Okay. If you still have any more problems which you need help with, we are still available to assist you. MSc Academy 24/7 helping students. So we are here for you. Just register for your monthly tutorials. You'll be assisted anytime, any day. We are here for you. Thank you.